30 years ago, if you had told someone that an unmanned airplane was on the prowl, they probably would have assumed something equally unbelievable. But not any longer. Today, all of us have heard words like drones, UAVs, UAS, or the UCAVs. Many of us even own our own unmanned planes that we fly around as hobbyists and/or for commercial purposes. By nature, both drones and the UAVs are unmanned, so why the different names?
There isn't a simple explanation because sometimes even a flightless vehicle is also known as a drone.
Drone platforms are either governed by a manned control system from start to finish or operated onto a specific path and dimension, navigating out of set of waypoints fed into their systems from a navigation database used by onboard flight computers. The UAS, on the other hand, is an elaborate aerial-only system comprising components of various types to make a specific mission happen. Most UAS known to us today happen to be military systems used for surveillance and/or combat missions, whereas the civilian applications are mostly in use commercially, like the Amazon's drone system for example, all set to receive clearance as the world's first drone airliner.
A UAV package, also known as the UAS, is mission-equipped, task, designed, and come in different shapes and sizes. For example, the Albatross, a 22-pound max takeoff weight commercial drone, can pack into your SUV, whereas you can pack your SUV into the Feihong 98, a Chinese commercial unmanned plane capable of lifting in excess of 1 ton.
Unmanned planes will have their sensors, different cameras including the forward-looking infrareds, weapons, communication, or other mission loadout. From tactical recognition capability to more complex information gathering tasks, until recently, military UAS have been an order of magnitude more complex than their civilian counterparts. Both carry an over 24-hour endurance and higher altitude capability on the further end of the spectrum and incorporate equally sophisticated control and processing systems. UAS have been used extensively in anti-poaching operations, video filming, farming, wildlife, police, traffic control, information surveillance, and reconnaissance missions, which are mostly military by nature, customs, border patrol, and combat missions. Much to the chagrin of the fighter pilot, the UCAV could soon be taking their jobs as well. Only recently, an F-16 flown by onboard AI scored total victory against its human adversary flying a similar platform. A UAS could function both line of sight and beyond line of sight. Most systems have a single internal pilot box into a plethora of support computers, also known as the ground control system. You probably did not miss seeing one of those containers housing the whole hardware and personnel, making line of sight and beyond line of sight inputs into their airborne platform. The beyond line of sight UAS are controlled via the satellite data links, a network capability of up and down links to send and receive information, systems and mission monitoring, active visual feedback, and more go into making a UAS operate beyond line of sight. UAS information can also be sent to wherever it's required, particularly to command centers and/or the headquarters. Unmanned aircraft is not a new technology. Planes that were originally designed to fly manned missions have been flown in this manner for long. Only recently, reliable robotics wired and programmed a Cessna 172, a normal category aircraft popular among flight schools across the world, into flying its entire flight plan as a UAS.
It is important that the basic theory regarding the UAS is thoroughly understood, and it is hoped that the IATC student will find these lessons useful during their career.